This assembly tutorial using MPASM version 5.81 Toolchain of MPLAB X IDE version 5.05 has a switch connected to pin 11 RA2 and LED connected to pin 2 RA5 of the PIC16F1705. RA2 is connected to a 10K pull-up resistor from the 5V supply rail, keeping the pin pulled high or a 1 when the switch is not pressed. One of the switch's normally open contact pins is connected to ground and the other pin to RA2. When the switch is pressed, the contact closes and pulls the pin voltage low for a sinking circuit, or active low. A person would expect this type of switch's contact to close and open immediately, producing a clean transition from open to closed or closed to open. But in reality, this type of switch's contact will actually bounce before settling to an open or closed state, as seen from the example of an oscilloscope measuring the switch's state and the bouncing normally open contact for both being pressed and released. During this short period, normally around 20 milliseconds, the microcontroller is able to detect these changes. This is due to the rather high frequency that microcontrollers operate at. For example, a 4 MHz system clock produces 1 million instructions per second. So, a method called debouncing can be used to filter out these unwanted bounces of the switch's contact, ensuring a stable state can be used in our code. There are various methods used to achieve this, basically using delays. The debouncing method will need to be used for both the switch press and release. For this tutorial, the switch being pressed will be used to turn the LED on, and if pressed again, will then turn the LED off, and the cycle will be repeated. RA5 has a LED connected from the 5V power rail through a 1K current limiting resistor to the LED's anode or positive leg. The LED's cathode or negative leg is connected to RA5. Pin RA5 is high to keep LED off, and when low, turns on the LED. This project's assembly file has been made available to download in both a text format and a PDF version. Use the text file to copy all text and then paste into your project's new assembly file, allowing you to easily follow along as we proceed. Please see the channel's community tab to access the download links, or use the links in any of this tutorial's video descriptions, which will be divided into various parts covering specific sections only. Thanks for watching this tutorial intro, part 1, which is followed by the device configuration with each line of code explained in part 2. Like, subscribe, and hit the notification bell to receive updates on videos as they become available.